Hello AWS users. In this video, we will present to you an end-to-end demo of how to set up single sign-on to Amazon Redshift using PingFederate as your identity provider and AWS Managed Active Directory as your LDAP data store with trusted identity propagation using IAM Identity Center integration. I'm Rohit Vashisht, Analytics Specialist Solutions Architect at AWS, focusing on Redshift. Architecturally, you need to set up SAML. Stands for Security Assertion Markup Language, an open standard that allows identity providers authenticate users by sharing their security information with service providers. So in PingFederate, this is done by creating browser SSO type SP connection. In order to propagate users' information from identity providers to AWS IAM Identity Center platform, we use an open standard called SCIM, which stands for System for Cross-Domain Identity Management. In PingFederate, SCIM is set up using SP connection of type outbound provisioning. PingFederate also requires a data store to manage your users and groups. Please note that for outbound provisioning, you must use LDAP-based data source in PingFederate. Cloud data sources like PingOne would not support outbound provisioning. When the users and groups are propagated to IAM Identity Center using SCIM, you can create a Redshift application and have your users connect to Amazon Redshift from Query Editor v2 client. To connect from other third-party clients like Tableau, you would require to set up token exchange using OpenID Connect, OIDC. That's not covered in the scope of this demo. Let's get started with the setup. The whole setup is based off of the AWS documentation on IAM Identity Center integration for different identity providers. Navigate to the PingFederate documentation and let's first take care of the prerequisites. We need to first install PingFederate, have the AWS SSO connector software added to PingFederate installation, then set up the SAML-based browser SSO connection. So first thing first, let's install PingFederate. So navigate to the AWS Management Console, change the region. We'll use US East 2 Ohio region for this demo. Open up the EC2 console and launch an EC2 instance which is good enough for your PingFederate server. You can install PingFederate on Linux or Windows. I'm going to use a M5 extra large Windows 2019 based server for this. I'm going to fast forward the EC2 instance creation and the login process. So you will select the VPC, security group, create a new key pair to help generate a password for remote login on RDP client. The EC2 instance is launched. Once it's up and running, we'll log in using a remote desktop client from our local machine. Okay, open the Microsoft Remote Desktop Client, enter the administrator username password that you generated using key pair, and that's it. You're logged into the Windows machine. Now for installing PingFederate, refer to the Ping documentation for installation. You would need to create an account on Ping Identity website and then download the installation software package from there. You can download the installation package on the Windows EC2 instance to get going. I had it downloaded before, so I'm going to use that same installation package to get started. Okay, double click on the PingFederate MSAD to start installation. It will complain for Java home not being present. PingFederate basically requires compatible Java version to be installed on the machine that you're trying to install it. It's explained in their documentation as well. So we will install JDK 17 as it's compatible with PingFederate 12.01. I tried JDK 22, the latest one, that wasn't compatible, so you can avoid that experiment. So install JDK 17, it's pretty quick. When Java is installed, go to the search bar next to the start panel on the bottom left. Type environment variables. This is where you will add the Java_home variable and provide your JDK 17 installation path. Okay, Java home is set. Try to run PingFederate MSI now. You need to keep clicking next, but I want you to notice the admin HTTPS port 9999 and HTTPS port 9031 for the server. These will be used in our setup ahead. Keep clicking on next and then finally click on install. Installation will progress. When successful, you will get a URL. This is the URL to access your PingFederate server admin console. If you are prompted for this URL safety, you can go to Advanced tab and proceed connecting to the URL. For the first time on your admin console, you will accept terms and conditions, set the base URL for your server access at port 9031, optionally connect to PingOne account if you have, add your license key, then set up your admin account credentials, and finally you will be able to enter your admin console. Now wait a sec. This is a server and you would want to access it from internet. with the credentials you just set up without having to enter the remote desktop and open a local host on port 9999 to enter the admin console. Let's set this up using Route 53 hosted zones and record sets. There's another reason why we want a fully qualified domain name for this server. I will share that very soon as we get there. So let's navigate back to AWS Management Console and open Route 53 service. Amazon Route 53 is a highly available and scalable domain name system web service. Route 53 connects user requests to internet applications which are running on AWS or on premises. If you do not have a public facing domain name, you can request it from Route 53. Using your domain, you can create a hosted zone, which is a collection of records within a domain. A record is a way to route traffic to the domain. I will be creating an alias type A record with name PingFedAdminConsole.my domain name, which will be automatically appended since I'm creating the record in my hosted zone. The alias record PingFedAdminConsole will then route the traffic to a load balancer, where the target group of the load balancer is nothing but our PingFederate server on the EC2 instance. So let's navigate to the EC2 console and try to create a load balancer and then come back and finish creating this A record in Route 53. Click on Create Load Balancer, then enter a name for this load balancer. Now we want to make it internet facing. Choose your networking, VPC, subnet, security group. In listeners, you will create a target group pointing to the EC2 instance. So click on Create Target Group. Choose the target type instances. Give the target group a name. In protocol, choose HTTPS, and in port, choose 9999 because ultimately we want our A record to open up the admin console for the PingFederate server. Leave rest of the settings blank until Advanced Health Check settings. Here you can change success code from 200 to a range of 200 to 499, since as of now we just want to see our load balancer health even if there is a forbidden code 403 written from the server. We just want to check reachability, if you will. Click on Next, select your PingFederate server instance and then click on Include as pending below for port 9999 on the selected instance. And then click on Create Target Group. If you forgot to click on Include as pending below earlier like me, you may also click on Register Targets and perform that Include as pending below action. Now come back to the load balancer wizard and refresh listeners list and choose the target group that you just created. Scroll down to select your security policy. You may go with the recommended one. For the server certificate, you can choose AWS's Certificate Manager service to generate one for your fully qualified domain name that you intend to use, which is PingFedAdminConsole.your domain name. So for that, we navigate to AWS Certificate Manager, aka ACM service. Click on Request Certificate, select Request a Public Certificate, and then click on Next. Type your fully qualified domain name, which is PingFedAdminConsole.your hosted zone name. I will leave remaining settings to default. RSA 2048 is a good algorithm choice, so click on Request. The request will be in pending validation state for a while. In order to validate, you would need to create a CNAME record in your Route 53 for it to validate. So you would click on Create Records in Route 53 button and then wait for a few seconds to a couple of minutes for it to validate the certificate. So after a few seconds, certificate was issued. So I go back to my load balancer wizard, refresh the ACM certificate and choose the certificate just issued. I'll scroll down and leave remaining configuration as is and click on Create Load Balancer. The status of load balancer will be in provisioning. Give it a minute or two to become active. Okay, after about a couple of minutes, it became active. Now let's go back to creating alias record in Route 53. You may not see your load balancer in existing page as there is no refresh button here for load balancer. You may want to create the alias record for PingFedAdminConsole.hosted zone name once again if you retry though. Select the application load balancer, US East 2 region. You should see the load balancer that you just created. Looks good. Click on Create Record. In a minute or so, the status of the alias record changed from pending to in sync. Let's try to refresh this fully qualified domain name that we have just created. That's a heartbreak. Nevertheless, we know that when we were on the remote desktop logged into the EC2 instance, it was working pretty fine. Let's try to reach the instance from the internet. I'll ping it from my local terminal and see what happens. Request timed out, so we are not able to reach the EC2 instance from the internet basically. It can be related to my security group for EC2 instance to have inbound traffic from my machine. I verified that's not an issue. Wait a sec. So I might need to open up ICMP, Internet Control Message Protocol, on my Windows instance. So I'll go ahead and do that. Enable ICMP. I'll go back to my remote desktop, open Windows Defender Firewall with advanced security, create a new inbound rule of type custom, let all programs access it, select ICMPv4 protocol, let it apply to all the inbound IPs, allow the connection and let the rule apply to all domains. Let's name it enable ICMP and click on finish. ICMP enabled. Let me try to ping it from my local terminal again. Cool, it works. Let's try to use our fully qualified domain name now that we created using the alias record in root 53. Sweet, we can now access the admin console from the internet. Okay, so we are logged in. Admin console looks good. Let me replace my expired license. Now, just like we created a load balancer and alias record for admin console, we need to create a load balancer and the alias record for PingFederate server itself on port 9031. The admin console was 9999 port. The server port will be 9031. The setup will be exactly same as what we did for the admin console. Why we are doing this? As I mentioned before, I'll share it as soon as we get there. I will fast forward this process a bit. We create a load balancer. While we do that, we create the target group of type instances with the protocol HTTPS and port 9031. We set up health check success codes 200 to 499. Then we select the instance and on port 9031, we click on include as pending below to register that target. Then we add the target group to load balancer. We further request a certificate from SCIM, the AWS certificate manager. The fully qualified domain name in this case will be pingfedserver.hostedzonename as opposed to pingfedadminconsole.hostedzonename that we used before. To validate your certificate, remember to create a CNAME record in root 53. When the certificate is issued, go back to the load balancer wizard, refresh and choose PingFederate certificate and finish creating your load balancer. Next, create an alias record with name pingfedserver.hostedzonename. The hosted zone name will be appended automatically. Choose US East 2 region and the load balancer that you just created and hit on create record. This will create the alias record for pingfedserver.hostedzonename. Now, why did we create these fully qualified domain names? The PingFed admin console was just for being able to access admin console from the internet, but the PingFed server on port 9031 will be used for our IAM Identity Center integration. For the metadata export that you will use for IAM Identity Center integration, the default base URL in protocol settings, that is, you will see the localhost name :9031, is not going to be resolvable by IAM Identity Center. If you use the metadata export as is, you will get malformed URL error because IAM Identity Center will not understand the localhost name :9031 URL. For the metadata export to make sense for IAM Identity Center, you will modify the protocol settings to use the fully qualified domain name for the PingFederate server. And then further, you will take care of other prerequisites like creating browser SSO connection for SAML. And then you will finally export metadata that you will import into IAM Identity Center. Since the protocol settings are taken care of, as you can see, let's try to create a browser SSO connection now for SAML. The metadata for browser SSO connection will be imported from IAM Identity Center, or we'll call it IDC. If this is your first time using IDC, you will first enable IDC. On IDC console, click on Settings. In the Identity Source tab, click on Actions, select Change Identity Source. Then choose External Identity Provider and click Next. In the service provider metadata, download the metadata file. This metadata file will be used to create browser SSO connection. After you have created the browser SSO connection and further exported the metadata from PingFederate, you will export the metadata file from PingFederate and upload it to the identity provider metadata section that you see below on the same page. For now, we go back to PingFederate admin console. Navigate to Applications, SP Connections and click on Create Connection. We do not choose a template for this connection. In connection type, we choose Browser SSO Profiles with SAML 2.0 protocol. Let connection options be Browser SSO. Import the metadata file that you exported from the service provider metadata in the IDC console. No change required in metadata summary. In General Info tab, feel free to use another ID or leave everything as is and click Next. Here comes an important tab, Browser SSO. This is where you will configure the single sign-on settings. In SAML profiles, choose IDP initiated and SP initiated SSO options. I want to leave the assertion lifetime validity time frame as is. Next is assertion creation. This is a mandatory section. Click on configure assertion creation. Choose standard identity mapping. In attribute contract, choose SAML subject to be email address rather than unspecified resource name. Click next. Set authentication source mapping, which is another mandatory property for which you need to map a new adapter instance. Now this is a whole new topic. Adapters are like containers for configuration information. You can have adapter instances for identity providers as well as for service providers. The mapping here is to specify the identity provider adapter mapping. Now PingFederate do not have a data store so far which really contains the user or group information. So what we need here is a data store. PingFederate supports a variety of data stores, but apparently when it comes to outbound provisioning that we are going to do later using SCIM protocol to send the user group information to IDC, remember to save the draft for SP connection. I was saying when it comes to outbound provisioning, PingFederate only supports LDAP based data stores. So cloud data stores like Ping1 are not going to be supported for outbound provisioning within PingFederate. The reason for that is because Ping1 already has its own outbound provisioning. So as a data store for this demo, we would use AWS Managed Microsoft Active Directory. It's an LDAP based data store. We will use AWS's directory service for this. Choose AWS Managed Microsoft AD and click on Setup Directory to get started from the directory service landing page. Leave the directory type selected as AWS Managed Microsoft AD, click Next, then enter your directory information. I'll use Standard Edition for the demo, recommend using Enterprise Edition for your business. Give it a name. I'll use the name to be pingfed.directory.myhostedzone name, just to have same domain name for admin console server and now the directory. The directory DNS will become domain component and NAT BIOS will become your organizational unit when you map these later from LDAP perspective. For this directory, there will be an admin user created for which you can set up the password. Ideally, we should be using services like Secrets Manager for this, but for this demo, I'll use a password that I can remember. I'll use this password later to access my data store, both in my PingFederate data store as well as in my LDAP Windows server. Click on Next, choose your VPC and then your subnets. I want to have this data store in a private subnet from security viewpoint. Therefore, I select private subnet with names private subnet 1 and private subnet 2 in US East 2B and US East 2C availability zones. Review and then click on Create Directory. Takes a while to create the directory, so we'll skip next 20 to 45 minutes and then resume the video. Alright, so hoping our directory is created. Yes, now we haven't created an instance yet, but that doesn't prevent us from testing the connectivity to the directory. So let's go and create a data store in PingFederate admin console. Navigate to System, Data Stores, give your data store a name. For type, select LDAP directory. In LDAP configuration, use the directory DNS name and click on Add. Enter user DN as admin and password that was set during directory creation. Choose the DNS name from dropdown and click on Test Connection. Test failed. Well, naming a directory as pingfed.directory.hostedzone name does not make it a fully qualified domain name, and thus it cannot be resolved. We can surely create an alias record pointing to the private IP of wherever your instance of the directory gets created. Alternatively, we can use root 53 resolver endpoints. Let me show you how to create root 53 resolver endpoints. On root 53 console, navigate to inbound endpoints under resolver. Click on create inbound endpoint. Provide your endpoint a name. Choose the VPC, security group, same as that of your directory. Endpoint type will be IPv4. Choose the availability zones that you used while directory creation. For me, that was US East 2B and US East 2C with names private subnet 1, private subnet 2. Click on create inbound endpoint after you're finished. Now similarly, you have to create the outbound endpoint. I'll fast forward this a bit because nothing much changes. The outbound endpoint creation is almost similar to inbound endpoint creation. Next comes resolver rules. This is what will set up your connectivity. Click on create rule, give the rule a name, type can stay as forward, domain name will be your directory DNS name, choose your VPC, select the outbound endpoint that you created, which also tells you that creating the inbound endpoint for resolver was not required. Then select the target IP addresses. These will be the private IPs of your directory created. Click on submit for this rule. The resolver endpoint and rules creation is quick. It's already complete. Let's test our connectivity for the data store again. Sweet. So the connectivity test successful. Click on next, review and save your data store. Now you need to set up password credential validators, which will let PingFederate authenticate users and groups coming from this data store. Under tab type, assign your validator a name and ID. It accepts string values. Type will be LDAP username password credential validator. Now under instance configuration, provide LDAP search query for the base DN. This will be based off of your directory DNS name and NetBIOS name. So I'll use OU equal to CORP, comma DC equal to PingFed directory, comma DC equals to my domain name prefix, comma DC equal to com. That will become my base DN. Now I'll pick the search filter criteria from the example syntax for Active Directory, which is SAM account name equals to $username in curly braces. Leave remaining settings as is unless you want to customize your password credential validator based on the company policies. Review and click on save. Password credential validator is ready. Now let's go back to the applications tab and resume SP connection where we left it and create new adapter instance. You can also create a new adapter instance by going to IDP adapters under authentication tab. In SP connection, IDP adapter mapping, click on manage adapter instances. Create new instance. In type tab, enter instance ID and name. It accepts strings. Type of adapter instance will be HTML form IDP adapter. Click next. In IDP adapter, choose the password credential validator that you just created and hit update. Configure settings for the validator. I'll leave them to defaults and click next. In extended contract, we only have policy.action and username in the core contract. Let's add email as well. In adapter attributes, you can pick a unique key, select a pseudonym or mask log values. I'll just choose username as my pseudonym and click next. In attribute contract mapping, click on configure adapter contract. This is where you will associate your data store. Click on add attribute source. Give the source ID and description. Any string should work. In active data store, choose the data store that you created. Type will be automatically populated as LDAP. Click next. In LDAP directory search tab, you will enter the base DN just like you entered the search base before. Domain component will be your directory DNS name. Organizational unit will be your NetBIOS name. So in my case, it will be OU equals to CORP, comma DC equals to PingFed directory, comma DC equals to domain name prefix, comma DC equal to com. Basically LDAP query search path. If you want to add attribute to return from search, choose them, else click on next. In LDAP filter, we'll use the same filter that we used before. SAM account name equals to $username inside curly braces. Review. Actually, I do want to get mail returned from the search as a mandatory attribute. So I'll go back to the LDAP directory search, choose show all attributes and select mail and hit add attribute. Now all looks good. I'll click on save. Adapter instance ready. Let's choose this adapter for IDP mapping. Click next. In mapping method tab, keep the default. Use only the adapter contract values in the same assertion and click next. In adapter contract fulfillment, For SAML subject, choose adapter source and then select email as the value. Leave the issuance criteria as is and click next. Review IDP adapter mapping and click done. You will be back to assertion creation tab. Finish it by clicking done. You will be back to browser SSO. Click next. In protocol settings, click configure protocol settings. Leave consumer service URL as is. In assertion SAML bindings, choose post and redirect only. Uncheck others. Leave always sign assertion. Leave encryption policy as is, which is none. Do recommend encryption for enterprises though. Review and click on done. You will be back to browser SSO. Click next to reach the final summary tab. Review and click on done. You'll be back to SP connection again on browser SSO tab. Click next to reach credentials tab. Click on configure credentials, which takes you to the digital signature certificate. If you already had a certificate to use, you can use that. Otherwise, you can create a new one by clicking on manage certificates and then clicking on create new. Give it a name. I'll call it AWS Managed MSAD Cert. For subject name, I want to use the DNS name of my directory in the value and click on add. Organization owning the certificate info can be added if you want to. Leave the checkbox, make the certificate active enabled and click on save. Your certificate will be created. Click on done. You will be back to credentials. Choose your signing certificate. Click on next to review or done to come back to SP connection credentials page. Click next to activation page. Leave the SSO application endpoint enabled to be able to test the endpoint. Review everything and hit on save to finish creating SP connection. As a review, my IDP adapter lacks one thing. Let me go to authentication IDP adapters to fix that. I'll keep clicking on next until I reach adapter contract mapping. Here I'll click on configure adapter contract. In the second tab, adapter contract fulfillment, I need email contract to have a value from source LDAP data store associated with the mail that will appear from search. The reason we did that is email was an extended contract attribute. We need to assign value to extended contract attribute. Keep clicking on next, done and save. We should be all set now from IDP adapter perspective. Now that our browser SSO connection is ready, let's export metadata from PingFederate using this connection and import it in IAM Identity Center. Go to System, Protocol Metadata, Metadata Export. In the Metadata Role tab, choose I am the identity provider. Click Next. In metadata mode, use a connection for metadata generation. Click on Next. Choose the SP connection with browser SSO that you just created. Click Next. Provide a signing certificate. Click Next. Review and click on Export button on the left. When finished, click on Done. Navigate to IAM Identity Center, Settings. In Identity Source, choose Actions, change Identity Source, select External Identity Provider, click Next. In Identity Provider Metadata, choose the metadata file exported from PingFederate. Click Next. Under Review and Confirm, review the consequences and when ready, type Accept and click on Change Identity Source. Now I'm tempted to click on that Automatic Provisioning Enable button so that all the users and groups from PingFederate data store will start syncing in IAM Identity Center. But hey, we did not set up the outbound provisioning via SCIM yet. Nor did we create an instance for our directory which will have our users and groups. So first let's create an instance for our directory where we'll add the users and groups to test. Now I want you to watch this section of instance creation till it succeeds, as I have deliberately added common challenges and their solutions during instance creation for a directory in private subnet. For your directory, click on Actions and choose Launch Directory Administration EC2 instance. I'll leave everything default except my security group that barely allows any inbound rules. Scroll down and click on Submit. Instance creation will be initiated. You'll see a progress bar in green at the top. Click on the View Details button in the progress bar to check for the stages of instance creation. Watch the execution status as it progresses. Step number 22, wait until instance SSM managed, will be timing out after a few minutes, and the overall status will become timed out. One of our AWS repost articles talks about it. When you navigate to the exact error documentation on repost, you will see that it requires you to create a couple of VPC endpoints, one for SSM and other for EC2 messages. Let's create these endpoints one by one. For that, let's go to VPC in AWS console, go to endpoints and click on create endpoint. Give your endpoint a name. Leave service category as AWS services. In search bar type com.amazonaws.your-region, which is US East 2 in my case, .ssm. Select the service, choose the VPC, subnets and security group, same as that of your directory, and click on create endpoint. If you look at step 9 in documentation, it asks you to repeat the same steps for another VPC endpoint com.amazonaws.region.ec2 messages. I'll create EC2 messages endpoint as well. Fast forward the creation. The steps are exactly same except it will be EC2 messages and service name in place of SSM. Okay, both endpoints created. Now we go back to our directory, ensure the instance attempted last time was terminated automatically, and try to create a new instance now for the directory. This time, step number 22, which is wait until SSM managed, it will not time out. But you will see step number 25, domain join custom, fail after a few minutes. If you click on that error, you will see a connection attempt failed since there was no response received by the instance well within time. Well, the connection times out because we are creating this instance in private subnet. There is no way to reach it as of now. The solution, which can also be found on AWS repos, is NAT gateway and an endpoint for directory service. So these two things will make the domain join possible. So let's create NAT gateway on the VPC console. Click on create NAT gateway, give it a name, choose one of the private subnets from a directory. Connectivity for the NAT gateway will be public. That would also require you to allocate an elastic IP address. That's it. Click on create NAT gateway. It takes a few minutes. Wait until the pending state changes to available. Now, in order for this NAT gateway to be able to access the instance and private subnet, you would need to add the elastic IP of the NAT gateway in the security group inbound rules. So copy the elastic IP for NAT gateway and click on edit inbound rules and paste the IP address with the /32 suffix. I have opened up all traffic in the rule type. Ideally allowing ICMP should be good enough. Now let's create the directory service VPC endpoint. Click on create endpoint in the VPC console. Give it a name. Service category should either be AWS service or other endpoint service in case if you don't find com.amazonaws.region.ds under AWS services. Either of the two places, AWS service or other endpoint service, choose com.amazonaws.region.ds. Select the VPC subnet security group like that of your directory. Click on create endpoint. Now let's go back to our directory and launch EC2 instance again. This time it will succeed. So to summarize, what you need to create an instance in private subnet with a closed security group is 3 VPC endpoints, SSM, EC2 messages, and DS. Then you need the NAT gateway whose elastic IP has to be allow listed in your security group's inbound rules. Your instance will be launched and it will take a few minutes to initialize. After that, you can access it from the fleet manager using directory admin credentials. Login using your directory's NetBIOS name, corp/admin as the username, password that you created during your directory creation. It's the same username and password that you use to create data store in PingFederate. When logged in, access administrative tools by typing in the search bar at the bottom left. In administrative tools, open Active Directory users and computers. Look for NetBIOS name, which is corp. Right click on users to create couple of users. I'll first do it for Ethan. Provide a logon name. This will become your username. Click on next, enter a password. If you don't want users to change the password themselves, uncheck user must change the password at next logon and click next and then click on finish. I never added an email for Ethan, so just right click the user Ethan and open properties. In general tab, enter the email. Recall our extended attribute email. This is required by the IDP adapter. Let's repeat this for Frank. Now right click on your NetBIOS name corp and click on new group. In group name, put finance, leave remaining settings as is and click OK. Do the same thing for another group, sales. Now go to your users again, right click and choose add to a group. For Ethan, choose sales. For Frank, choose finance. Alright, we are done with creating a couple of test users. I'm hoping we are done with all prerequisites at this point and can set up outbound provisioning using SCIM protocol. Let's review the AWS documentation to confirm that. So I see prerequisite number 2 has not been taken care of. So let's take care of that. So from the prerequisite number 2 which we are missing, click on the link that says IAM Identity Center Connector. PingFederate page will open. Download the software You can do all of that directly in a browser in the PingFederate instance. I downloaded it on my local, so I'll just copy paste it to the remote instance from local. It's a zip file with name pf-aws-sso-connector-1.0.zip. Let me show you why it's required for outbound provisioning. Let me go to the SAML connection that I created with browser SSO. I will edit the connection type to include outbound provisioning. I do not see AWS SSO connector drop down in the list. The software that we downloaded from the zip file will bring it to our PingFederate server. So how do you add that software? Well, it's specified in the PingFederate documentation. The link that you downloaded the software from also had a documentation tab. If you click on that, it brings you to the provisioner page. Navigate to the setup and then deploying the integration files tab, which tells you what to do. It also covers how to modify the run.properties file. Like what's mentioned, go to your task manager, services, stop the PingFederate service, go to your PingFederate installation directory. In the server/default/deploy directory, copy paste the jar file from downloaded zip file. It will be inside the dist directory of the zip that you downloaded. Now for the second change, modify run.properties to change pf.provisioner mode to standalone. I need to go to the bin folder of the PingFederate installation. Open run.properties, find pf.provisioner mode and change it from off to standalone. Save this file. Now go back to Task Manager, Services and start the PingFederate service again. Log in again to your PingFederate admin console and then go back to your connection to check the connection type outbound provisioning. Now it should show the AWS SSO connector. Perfect. That also means that all our prerequisites are met. Let's start outbound provisioning. Step 1 is required to copy values from SCIM endpoint and access token. I'll do this when I'm ready to paste. Let's start step 2. Configure provisioning in PingFederate. Keep following the AWS documentation on PingFederate admin console. So we go back to SP connections. On connection type, choose outbound provisioning. Select AWS SSO connector. Keep clicking next until you reach outbound provisioning tab. On outbound provisioning tab, click on configure provisioning. On target, you paste the values from step 1, which is getting SCIM endpoint and access token from IAM Identity Center. For that, you have to go to IAM Identity Center console and enable automatic provisioning. This will generate the SCIM endpoint and access token. Copy and save them. We'll paste these two values in the target tab. Now go back to SP Connections target tab where you were and paste the SCIM endpoint and access token that you copied. Leave others as is unless you want to change access settings. Click on Next. On Manage Channels, click on Create. On Channel Info, provide the channel a name, something like AWS IAM Identity Center channel that's there in the documentation. Click on Next. On Source tab, select the Active Data Store as the data store created from AWS Managed Microsoft Active Directory. Type will automatically become LDAP. Click Next. I'm going to leave source settings as is. In source location, you will use the base domain name similar to what you used in the search base of password credential validator and also in the base DN of the LDAP directory search during adapter contract mapping creation, which is OU equal to CORP, DC equals to pingfed directory, DC equals to your domain name prefix, DC equals to COM. Use user and group filters as object class equal to user and object class equal to group respectively. Attribute mapping need not be changed. Finally, review all changes, ensure your channel is active and click on Done. This will take you to the configure channels with the channel that you just created. Click on Done. This will take you back to SP Connection, Outbound Provisioning tab. Click on Save. We are all set with outbound provisioning. Now to check how provisioning is going on, you can go to PingFederate installations log directory. The latest provisioner file will show you the status of provisioning of users to IAM Identity Center. You can also check that by going to IAM Identity Center console. Clicking on Groups and Users tab. I see Ethan present, but Frank is missing. Let's look at provisioner again if there are any errors. So I see there is a work email mapping error. I think I forgot to add email for Frank when I created the user in Active Directory EC2 instance. I'll add that. I'll refresh IAM Identity Center users. And there we go. We see Frank now. Provisioning looks good. Now we'll have these users connect to Redshift using Query Editor v2. Now AWS has published a very nice blog with Okta as the identity provider. I will follow the blog to set up Redshift application and connect to Redshift using Query Editor v2. So let's do this. Navigate to the Amazon Redshift console. In the Explorer menu, click on IAM Identity Center Connections. Click on Create Applications. wizard will open. You will see instance of IAM Identity Center in step number 1. Click Next. In step number 2, you will enter connection properties. The application display name for IAM Identity Center integration. I'll use PingFed IAM IDC Redshift app. Unique managed application name will be auto-generated. Give identity provider namespace a valid name. AWS IDC is presented by default. IAM role for identity center access should be based off of the policies in the blog. I'll keep on adding these policies to an existing role, demo Redshift role. Edit trust relationships for the role to match required access level. Add another inline policy to add the permissions required for IAM Identity Center integration like it's mentioned in the blog. For modifying the inline policy, the SSO instance ID can be obtained from IAM Identity Center console. I'll keep making the changes quickly as I'm just following the documentation as is. The role is all set with required policies. Continue with IAM Identity Center connection application creation in Amazon Redshift. Check Enable Query Editor v2 application. Leave trusted identity propagation as is. I'll also skip the fine-grained access control in lake formation. Click on Next. In step 3, client connection through third parties, select No. We'll probably do another video or blog for that. Click Next. In step 4, review and click on Create Application. When application is successfully created, go to Groups tab and click on Add or Assign Groups. Type the groups that you want to add to the Amazon Redshift application. This is where you can choose which groups out of all provisioned in IAM Identity Center need to be brought to Amazon Redshift connection. We will add sales and finance. Log into your Redshift serverless data warehouse as an administrator. Copy paste the test scripts from the blog. Execute the create identity provider statement, the create role statement, the create schemas and table statements, and then finally grant sales role access to sales schema and finance role access to finance schema. We expect Ethan from sales to be able to query a table from sales schema only and Frank from finance to be able to query finance schema only. Next step is to create permission set in IAM Identity Center. Go to IAM Identity Center permission sets and click on create permission set. A wizard will open. In step number 1, choose custom permission set, click Next. In step 2 under AWS Managed Policies, add the permission for Amazon Redshift Query Editor v2 read sharing. In inline policy, add the policy for Redshift and Redshift serverless access. You can copy paste it from the blog. Click Next. In step 3, give your permission set a name and description. You can also set session duration for your users. Add relay state for SQL Workbench. Click Next when done. In step 4, review and click on Create. When permission set is ready, go to AWS Accounts in IAM Identity Center. Choose the member account from your organization for single sign-on access and click on Assign Users or Groups. Choose Sales and Finance groups in step 1. Choose the permission set that you just created in step number 2. Then review and click on Submit in step number 3. Your member account will be configured. Now you are ready to test the user access for Ethan and Frank. From IAM Identity Center, Settings, go to Identity Source tab. You will find the AWS Access Portal URL that you can share with your users. I'll open this URL in 2 different browsers, one each for Ethan and Frank. First log in as Ethan. We will see the member account, expand it to find the permission set that we just created. Click on it to open the query editor v2. Let's run a select query for Ethan. Good. Ethan is able to query from sales schema.store sales table. Let's open another browser for Frank. Trying to run the same query, we get permission denied for sales schema, and that is expected. Let's query finance schema.revenue table. Okay, Frank is able to access that one, so that's good. So this is all that we wanted to cover as part of this particular demonstration. This was a demo of single sign-on to Amazon Redshift from Query Editor v2 client using PingFederate as your identity provider and AWS Managed Microsoft Active Directory as your data store with IAM Identity Center integration. I would like to extend special thanks to Jared Warren, Principal Solutions Architect at AWS, and Manish Sharma, Senior Database Engineer in Redshift team, for their help in this topic. Hope this was insightful. Thank you so much for watching.